Good morning, everyone. My name is Akshit Srivastav, and my teammates are Shubham Prajapati, and my team name is Cooltech. So, here at Innomatics Research Labs, we are participating in a hackathon. So, the I have selected the theme one automated OMR evaluation and scoring system. So, the problem statement states that they conduct regular placement readiness assessments which access role like data analytics and AIML for data science with generative AI course. So they have handed questions in the OMR sheets, and they have distributed five subjects, 20 per subject. So the evaluation is mainly happen manually. So they said to you have to prepare a system where you have to upload the OMR sheets. Then, after pre-processing, you have to show the results of each student and each of everyone. So, we have a solution where we will capture the OMR sheets after pre-processing, like correction for rotation, skew, illumination, and perspective distortion. After we will doing bubble detection and evaluation with using the OpenCV by Python, and also then after we will use answer key matching, then the result generation, and it will be a web application as you can see on the screen. So let's have a first walk around with a demo of it. So we will have to upload the files. So this is a key they have given. So here we have two sheets in this key Excel file. So sheet set A and set B. So we have also a feature of a JSON file, which will be a very effective and has a high accuracy. So after you have selected your sheet, you have to upload the OMR sheets. So here I have chosen set B, and I have 10 sets of answer keys. So I have to open, and here you can see they are uploaded. Now you have to select the large batch mode for images 200 plus images of number. So here I have only 16 images, and now here are the button we have to calculate it. After clicking this button, it has shown me the answer where you can get the status and results for cross checking, and you can see here the data. Here the file name, which we can say you can be given a unique ID for each students. The set for the evaluation, the subjects are here, and the total marks. You can see this result as maximize, or if you have to download, then you can click here. We have also a chart distribution, the where the data is then visualized graphically, and after that we have also options where we can download Excel results or the file as CSV. If we download the Excel results, the file has been saved here. Now this is a file where you have data of each and every student containing. So let's move to the UI part. Here we have three themes supported, and the website or the web app can accommodate maximum of four set version. So this will be the overall structure. Now let's move to the coding part, where we have implemented, or I can explain you the code in about four steps. The steps are divided, or the chapters are divided into four. The code is uploaded on GitHub, and it is live, and it is fully deployed on Streamlight. So let's discuss the tech stacks we are using here. So let's move to the code part. So first we will see the Streamlight user interface. So here this is the Streamlight app, and the first part is about all about the CSS. about the distribution of columns, grids, and coloring. After that, how we have implemented the template. So we have used Streamlight as it is a lightweight, and Pillow for image, NumPy for the data analytics, Pandas for data visualization, and OS for accessing the images, and JSON for the JSON file. So here we have inject CSS with the function name inject CSS. After that, these are all the styling option, and this is a status matrix which we will check the number of files uploaded, number of files loaded, number of files processed. This is a sidebar where you can select the seats, version, and the themes. So this is the main area where you have the evaluation sheet or the key file where we have to upload the key file. This is the optional which I can show you it. So this is a threshold value where you can select the threshold finding according to your needs. After that, we have column 2 which represent the evaluation button. Now let's move to the API part or the answer key management part. The first we will be uploading the file. After uploading the file, we will be checking whether it is an Excel file or not. Or after that, after checking, we will be dividing the sheets into set A and set B, maximum of 4 sets, and then after that, the parsing of the answers like question 1A, 2B, like that. So here I have prepared a document where you can see that Excel file format here 1A, 2B, like that. After uploading the key via the Streamlight, it will be like this. So under the hood, the file will be work like user uploads Excel, it will handle sovereign file data, service reads Excel, service parses content, like this. User will have the Streamlight UI. After that, answer key services. Now let's dive to the code. So in the services key.py, where we will parsing the Excel file. So this is the snippet. After that, we will be extracting question numbers and the options like this. So in chapter 2 we have covered the answer key management. Let's move to chapter 3, which is OMR template management. So it is a template like we will be creating a region of interest where we will be storing the rectangular area and calculating the bubbles. We have a coordinates and normalized coordinates. So it will be like a gist template structure, and we help with a threshold, minimum margin, scale, x and y offsets values. After preparing the JSON file, we will be implementing in the UI, which is because the JSON file is very accurately give the performance. After that, we have a OMR template .py in the F folder where we have in sliced, or you can say that make the algorithm. So these are the snippets you can see. So in the conclusion of the chapter 3, we have seen the neural grid system and the template management using JSON templates and normalized coordinates, where we will define these ROIs and how to use this the UI to upload templates and fine tune alignment. So let's move to the next chapter, which is OMR image processing pipeline. This in this chapter we will be cleaning up the image precisely locate bubbles and detect the filled marks and extract answer. We will be firstly created will be making the correction in the orientation, then the rectification of the perspective angle. After that, we will be applying the template, extracting bubble regions, calculating fill ratio. See, here is the user. User will be upload an OMR sheet, the Streamlight UI with the help of the Streamlight UI, and it will click evaluate. Then the Streamlight UI will send a raw image or template setting. Then the OMR processing pipeline will give the raw image for cleaning, where it will detect the orientation, rectify the perspective, and then after returns the clean image. Then the clean image will be returning to the detection service, where the image will be, where the bubble will be extracted, and the answer will be evaluated. Then these of the detected answer will return to the OMR processing pipeline, which will return the results and the Streamlight to the Streamlight UI, and the Streamlight UI will display the scores, charts, and other visualized reports to the user. This is a flow of the how the image will be cleaned and how the it will be given to the user. So here we are, this is a code for intensity, the thresholding. So we have seen the chapter 4 where we will be image processing and other pipelining, doing the pipelining for how will the image will flow from raw image to the clean image after manipulating the perspective and orientation. Now let's move to the final chapter, which is evaluation results and persistence. Here we will be solving the results and calculating the marks. It will be the digital gradebook schema where we have implemented the database schema. The UI will be asking whether to save the data in database or not. With this option, after that you will be using having a how to use evaluation result and persistence, the database storage, and this is under the hood of the flow of saving results. Here you can see the user will evaluate, process OMR sheets, it will post results, the database module will calls upside student, it will now create evaluation scheme. After that, the create student record will save in the database, or you have will not or not. If you haven't taken take on that, after that the confirmation will save, evaluation saved, and confirmation success, and the result and success message will be deployed to the user. So this is the models.py file. Here the ID, student code, sheet version, all the schema of the database. This is a CRUD operation file where you will be having the create, read, update, delete function, and this is the routes where the API endpoints, this post method and get method. This is a Streamlight API file, Streamlight app file, which will be saving the data according to the need of the user. Now conclusion. We have evaluation results and persistence. So we have seen how will the database will save the image and records the file. Now let's move to the backend part, which is the final part of our tutorial. Here the API. These are the API and the backend. We have used Fast API Python framework, which is very easy to set up. Now we will see how the app will works. The user will upload the image and it will be forwarded to Streamlight UI. And a post request is created and evaluate the. Then the API will send the image and sheet version to the Fast API backend. This will give the image to the OMR logic and calls evaluate image function with image data. Then it will return the detected answer and score to the API, and then the API will be send the JSON result to the Streamlight UI. After that, The results will post to the API backend, and it will send to the database for creating the evaluation and recording. After the confirmation message for the save in data, the database will tell the API backend that we have the saved the data, and we will now the fast API backend will send a success message with a JSON format, and it will display by the Streamlit UI to the user. And here it is a main.py file, a main application where will the have checked the first status of the server. After that is the endpoint of the UI API. After processing OMR images, these are the results endpoints. Now we have understood the vital role of the fast API backend role in the OMR neural grid system. It will act as a receptionist and processing center, providing a structured way for the UI to communicate with the core OMR logic and the database. We have seen the concepts like APIs, endpoints, and HTTP methods. How will the UI implicitly uses this to evaluate images and save result? And this is the end of the journey where we have understand how the OMR neural grid worked. So that's all for today. Thank you for watching.